So first of all, thank you everyone for attending this Tech Tuesday walkthrough. We're going to take a look at app-to-app messaging services, our smart contract management feature, and then some basic REST APIs for interacting with your Solidity code on chain. I'll start with saying I sincerely hope everyone is staying safe, staying healthy during the virus and during all of the social unrest. These are very, very new and tumultuous times. So hopefully this technology and some new fun features in blockchain can be a nice, healthy distraction. So let me just run through a few of these slides and then we'll jump right into the product. Just for everyone's context, I'm going to spend the majority of the time focusing on app-to-app messaging. It's a feature that we haven't dug into too deeply in the past. We've looked at a lot of document store features, a lot of event streams, a lot of our cryptographic techniques that are built into the platform. App-to-app messaging actually leverages a lot of these same constructs. So it's quite interesting that I haven't chosen to show it yet, but if you have seen the document store services, you'll be very, very familiar kind of with the asymmetric cryptographic flows and the Kafka pipes that help these documents and help these messages and help these payloads securely move within Kaleido. Just so to give everyone a very high level idea of Kaleido, very much use case business agnostic, built for modern business networks, completely applicable to healthcare, finance, supply chain. We provide the infrastructure, the runtime, the componentry, and all of the easy buttons so that you can focus not on the infrastructure, not on the back end, not on the crypto P2P layer, but on your business logic and ultimately on the end application that's going to be leveraged by your customers or by your company. You'll see this in abundant apparently, but the product and the platform itself is radically simple. So within the console, everything is click button simple, whether it's deploying a service or whether it's onboarding a new member. But there's also very, very easy and clean REST APIs behind all the services and behind all the admin operations as well. So you have the ability to build, a very, very simple application, leveraging all of our components, and also build out your own admin dashboards as well. And then lastly, we have a whole slide that touches on this, but very, very much built for the enterprise DNA in the heart of Kaleido. This is kind of how we've tried to approach the adoption of the technology and the ultimate, goal moving into an MVP, a pilot, or a production phase, making it completely simple, to adopt enterprise Ethereum, enterprise Corda, not concerning yourselves with managing those nodes, managing certificates, managing private keys, giving you the infrastructure, giving you the platform to very easily decentralize and start sharing this IT ownership over time, allowing you to onboard organizations and even embed governance and permissions. And then lastly, once you've built out that solid MVP, that solid POC, having the confidence to run this thing in production at scale, across multiple clouds, across multiple geographies as well. Quick snapshot of some of the very diverse customers running in Kaleido, and we see here that this spans finance, energy majors, government agencies, retail, entertainment, and this is really an attestation to the fact that Kaleido, what we do and what we're really, really good at is giving you those building blocks, giving you those components, but then you as a subject matter expert in your own industry, in your own vertical, you have the ability to leverage those components and solve your own problems, provide real value for your own industry. Some of the DNA things, enterprise DNA that I touched on at the beginning, ISO certified, really flexible techniques for key management, whether you want to have those private keys managed externally, managed in a Kaleido wallet, managed in a node, or even held in a cloud HSM service for delegated signing. PKI X509 identity techniques built in. We'll actually look at this today, some of our enterprise identity constructs, and then just HA, DA, auto scaling, best of breed open source clients and algorithms. You get all of these out of the box at Kaleido. And additionally, some very, very powerful cloud integrations with key management services, with logs, with backups, and with private networking as well. Last thing I'll touch on, We are a basic SaaS service, so there is standard pay as you go, where you can graduate up from our starter to our team to our business and enterprise tiers, and essentially, just put your credit card in and use all the resources that you need. But we also have, a really deep and rich number of packages that cater directly to whatever stage you are at, whether it is development or sandbox, or whether you're getting closer to that MVP pilot or even production phase. So I'm going to chuck my email into the chat, and we can talk offline about more of these packages and learn more about budget and use case if anyone wants to go that route. So those were the slides. Tried to keep it quick. And now we'll go ahead and jump into the product. So like I said, what we're going to focus the majority of the time on today is this app-to-app messaging service. And this follows a very similar flow as our private document exchange service, where we have the ability for different programs, different client applications to securely communicate with each other. So this could be just an ACK-NACK, this could be a finance, this could be I guess a litany of circumstances where we don't need large payloads being transferred, but we need, small frequent messages being exchanged across your business network. These can go hand in hand with a lot of the other services we have on Kaleido. But at a very high level, how this works is this is going to leverage our on-chain registry, what we call our ID registry, that has organizational enterprise identity constructs, digital X509 PKI-backed certificates. These can go through a self-signed Kaleido ceremony, or you can go through your own key ceremony, create a certificate signing request, and send these objects up to a reputable certificate authority, a DigiCert, a VeriSign, a whomever. Once you've established those on-chain enterprise identity constructs, beneath them, you can start to have key value pairs that have impact on your organization in Kaleido. One of these key value pairs that we're going to use today are what we call destinations. You can think of those as the inbox or the topic that the application wants to subscribe to and wants to communicate with. And associated with that inbox or that destination is a public certificate. And this is where we leverage asymmetric cryptography in Kaleido. We have client A in the demo I'm going to show you. We're going to have a sender and we're going to have a receiver. And the sender, client A, is going to use the public certificate of client B to encrypt those payloads, ensuring that only the counterparty, only the recipient of these messages is going to be able to decrypt them. This will be the only individual, the only organization, the only entity in the network that has the corresponding private key with their public certificate. So it's very, very basic asymmetric cryptography, but the actual security and the transfer of that is a non-trivial action. So this is really, really powerful in an enterprise context. And again, if there are any questions about PKI, about how Kaleido does identity or about the services, just throw them into the chat. Okay, so I have a consortium, I called it Example Network Consortium, and then I have a handful of environments. I'm going to try to go through this from scratch live, but if I get in a pinch, I have a prod environment that has some existing app-to-app services, has all the identities instantiated on the chain, and it has all those destinations created. So we'll try to do this from scratch, but if we're unable to, I may hop back to this prod environment where I've already confirmed that everything has worked. Okay, so the first thing to take note of at our consortium level are our memberships. These are our organizational identities. In this circumstance, these are both owned by my organization, but when you start decentralizing your business network, your consortium, you're going to have autonomous unilateral individuals and organizations that are in control of their memberships. So just imagine that these were owned by different organizations, that they weren't owned, solely by me. And then what we see here next to it is we see a certificate on each of them. And what I've done is I've self-signed a certificate. I've created an organizational identity for each of these memberships. And this can then get married with an Ethereum address. And this forms the top level, I guess the top of the pyramid or the top of the ladder for your organizational identity. So there's two flows that happen in this circumstance. You have to prove that you have ownership of the corresponding private key to the certificate. And then when you want to layer on key value pairs within the iChain registry, you have to prove that you have control of the private Ethereum key. And we'll actually take a look at the service, and this should make a little more sense. But what we see here at the consortium level is every participant, every organization has the ability to download and parse this public certificate. So they're able to download that and they can parse that back up to ideally what would be a reputable certificate authority. A lot of those constructs that we talked about, these asymmetric cryptographic approaches that we have, they're mandated on the existence of the on-chain registry and organizational identities. So Kaleido gives you this self-signed approach so that you can leverage these constructs without having to do an inordinate amount of key management, become an expert in cycling keys and cycling certificates and doing certificate signing requests. So we give you basically both ends of the spectrum. You can have full control of all of the private keys for signed verify operations for your organizational identity, or you can use the Kaleido easy buttons, or you can kind of meet in the middle and do a combo of each. So however comfortable your organization is with key management, with doing sort of sophisticated, elaborate application development and handling all of these sign verify operations programmatically, you have that option, or you have the absolute easy option where you click a couple buttons and Kaleido is going to do all that heavy lifting for you behind the scenes. Okay, so let's hop back to the network and now let's go into our environment. So here's my demo environment. I stood up a handful of nodes. 2 of them are owned by ABC, one's owned by XYZ. This is an IBFT environment, so I went with 4 nodes total. And then we see here that we have our on-chain registry service. So I'm gonna go ahead and hop into this service. And we see that we have those 2 certificates. We have those 2 self-signed organizational certificates. I took the easy route rather than doing my own key ceremony. But now what it's asking us to do is it's asking us to take a proof of that certificate and some arbitrary Ethereum address where Kaleido is going to control that key and create an on-chain profile. Actually upload this data to a smart contract on Kaleido. And then once we do that, those destinations, those inboxes, so to speak, and those corresponding certificates, those are going to get to live as children, as key value pairs within this smart contract. So we'll just go with the happy path here and establish the ID for ABC and XYZ. And again, if something goes wrong, I'll just hop back to my existing environment where I've already configured all of this. So this is an actual on-chain transaction. This is an invocation of our on-chain registry smart contract where we passed it a proof of that cert and we passed it some additional details. So I'll establish the identity of both of these and then we can take a look at how that looks within the scope of that smart contract. Okay, so here's our 2 memberships. So here's ABC, excuse me, we have the PKI identity. We can download that proof, that JWT, and we can also download the certificate. And we see here that there's an Ethereum address associated with this organizational identity. If you do this key ceremony yourself, of course, you're going to own the private key for this Ethereum address. In this context, it's really just a convenience utility. So here's the profile for ABC. We see that there's no key value pairs underneath it. This is what we're ultimately going to populate. And then here's the profile for XYZ. Same stuff with no key value pairs beneath the profile. Okay, so that was step 1. Now we want to go ahead and create 2 app-to-app messaging services. We want each of our memberships to have a service instance. So I'll just use the Kaleido convenient drop-down button. Again, this could be deployed with an administrative API. Everything I do here that I'm going to show you can be done with an API. So I'll grab a service for ABC. And then I'm going to grab a service for XYZ. And we'll give these guys a few minutes for those pods and those containers to properly come up. So we'll drag our feet here for about 20 or 30 seconds and we'll let these services come up. And again, if there are any questions, feel free to raise your hand or just go ahead and throw it into the chat. And yes, this will be recorded for folks that are curious, and we're happy to share all the slides and even recordings of previous Tech Tuesdays and Walkthrough Wednesdays. While I am dragging my feet, allowing these services to come up, here's the first guy, I made it up. I should note that tomorrow, noon Easter, we're going to do a walkthrough of Corda on Kaleido. So we are now truly multi-protocol, offering all of those great enterprise variants of Ethereum, Geth, Quorum, Hyperledger, Besu. But now Kaleido also fully supports Corda OS with a fully managed non-validating notary. So if you are comfortable with flows and Corda contracts and jar files and core dApps, that may be something that's really, really interesting to folks. And the ability to just kind of see Corda in the context of Kaleido, going through these exact same flows and these exact same processes, but dealing with a completely new and different protocol. It's quite exciting. So I'm going to do a hard refresh and see if this guy is waiting to come up. Okay, so there he goes. All right, so we have our two service instances, right? And again, the most important construct that we need here is we need a destination for each of our services. There's going to be an API, there's going to be a Socket.io WebSocket connection that's available for the applications to connect to, but they need to have those PKI constructs. They need to have those inboxes or those destinations that have the certificates associated with them. And the prerequisite before we could create those certificates, remember, is we needed to establish those organizational identities on the blockchain within that smart contract. So I'm just going to rename this right here if possible. Okay, looks like that's not possible at the moment. So we'll go ahead and create the destination for the ABC instance first. So it says that we've deployed the on-chain registry and we've registered our membership on-chain. That's great. So now we can go ahead and create the name for our membership. Now, again, if you do want to do the fully managed, I guess, key custody for these certificates, for these PKS7 certificates, and for all of these sign verify operations, Kaleido is going to say, okay, you can go that route and we'll give you ad nauseum documentation taking you through it. If you do want to just let Kaleido create those public-private key pairs and certificate, you can go with the easy route. And that's what I'm going to show here. So we're going to create an inbox or a destination that's called ABC here in this circumstance. And then after this works, we're going to go ahead and create a destination for XYZ. And then we'll configure our applications, our sample apps, and we'll start interacting. So here we see the two important endpoints. This is going to be for the Socket.io connection, and then this is going to be the actual inbox that one of the entities, one of the organizations is subscribed to. Now, bear in mind, you can have many, many destinations or many, many inboxes within your service instance. So it's very easy to compartmentalize and separate your different business segments and your different business logic. So you're not limited to a single service instance, nor are you limited to a single destination within that service instance. So you can go as broad or as granular as you'd like to here. So I'm going to hop out of this. I'm going to go into the XYZ instance, and we're going to do the same thing. Click the Add Destination button. Now, some of you that have been participating in these walkthroughs and have seen the new version of Kaleido, the next gen or the V2, may be wondering why I'm using the old console. And the answer is we haven't migrated the entire suite of Kaleido services to the version 2 of the console. Some of the ones that are going to be coming online here in the very, very near future are our B2B communications. So our document stores and private document exchanges, as well as this App2App instance here. We're also going to see a revamped version of the on-chain registry smart contract and our Ether faucet, just to name a few. Okay, so here we can see our owned destinations, the XYZ destination that I just created, and then we can see all of the available destinations that we could send data to that we could use for our App2App messaging instance. Okay, so now the last thing we need to do is we need to go ahead and configure our two applications that we're going to demonstrate here. So I'm going to hop back to ABC's instance, and the scenario that I'm going to show as I sort of tried to talk through in the diagram is we're going to have the ABC instance, the App2App messaging instance, be the sender of some arbitrary string, some message, right? Some ACK or some, payment information, some data that fits into your business use case. And that's going to travel through the Kafka plumbing, through Kaleido, and then that's going to be received by an App2App instance for XYZ in our circumstance. They're going to be subscribed to their inbox, and they're going to get automatic real-time notification when any messages are delivered to that inbox or to that destination in the Kaleido nomenclature. So that's the story that we're telling here. And then here's the app that we have. So I have an App2App library here, and we have two programs. We have two Node.js programs, a sender and a receiver here. And these are kind of the endpoints that we're concerned with. We need that API endpoint for the Socket.io connection. We need secure application credentials, right? There's boundary security on every ingress and every service in Kaleido. And then we need to know about the inboxes. We need to know about our inbox, right? This is who we're signing on behalf of. And then we need to know about our recipient's inbox. This is who we're encrypting on behalf of. And then we have a simple little string here that we're passing as our content, and we're choosing the interval in milliseconds of how often we're going to send this. So when I kick off these applications, you're going to see a ton of messages just get pelted into the receiver's program or into the terminal that I'm using to show that. So we need to go ahead and configure these strings, and we'll start with the API endpoint for the WebSocket connection. So this is for ABC. So we'll go ahead and grab this guy, make sure I'm in ABC. I am, okay. And we'll just start overwriting these placeholders that we have here. So we'll paste that. Now we'll go ahead and do the destinations. This will be the ABC destination. This will be the XYZ destination. So I'll copy that right there for ABC. We'll overwrite that placeholder, and then we'll copy the destination for XYZ. And I have this all available to me on a single screen, and I could also retrieve all of this via one of our APIs, a service or an admin API. Okay, so we'll paste that. I'm going to leave it at 2000 milliseconds, and I'm going to leave it as testing 1, 2, 3. Nothing exciting today. But the last thing that we really need, this would not work without it, we get a 404, is we need these these strongly generated application credentials. So I'm going to hop out of here, and I'm just going to go with the classic route of creating app creds. So we're creating these for ABC, call them whatever you want, ABC 1, 2, 3, click next. And again, Kaleido doesn't store these. This is salt hash on the server side on the back end. So you as the operator, you as the admin, you as the developer, you need to have your own custody techniques for these application credentials. You can always regenerate new ones. You can always cycle them. You can always delete them, but they're not going to be persisted. That password will not be able to be shown to you again. So let me make sure I've copied this. And then we'll overwrite these last couple placeholder values here. And we'll grab the password. Okay, so let's save this. So we're good with the sender program here. We updated our 2 destinations. We updated our API endpoint for the Socket.io connection, and we just created some application credentials. And now we need to do kind of some of that same heavy lifting for the receiver application that we have over here. This is XYZ again. So hop out of this. Let's go into the XYZ instance for App2App messaging, and let's copy its API endpoint for that Socket.io connection. And all of this code, all of these steps are available in the Kaleido docs. So this isn't proprietary code or isn't any custom code that I've created behind the scenes here. This is available for everyone to leverage, and all of these APIs are really simple and really easy to understand. So the last thing I need is I need the destination. This is what the receiver program is going to subscribe to. He's going to be listening on this and say, hey, let me know every time an app or a message is sent to this endpoint, or this inbox rather. So this is what he's subscribed to. And then the last thing we need is we just need some application credentials for this guy as well. So we'll go with the same route, switch our membership, XYZ. Again, call them whatever you want. This is just an arbitrary string. And then save this. Okay, so now the moment of truth. If I copied and pasted everything properly. So let's save our 2 programs. And now we can go into our terminal. So here's proof that it actually worked earlier, but that's less exciting than seeing it work in real time. So the sender is on the left. This is the ABC instance, and the receiver is over here on the right. And again, this is just a basic little node program. So we can kick off the receiver over here. Say node receiver JavaScript. Okay, connected subscribe. That means my endpoints were good. And then node sender. And this will actually take maybe 10 or 15 seconds. Oh, okay. So I misconfigured something for our sender. No problem. Let's go ahead and make sure we got everything right for the sender. Bear with me. Sorry about that. Okay, back to the sender. Okay, API endpoint, copy that. Paste that. Application credentials from and to. Let's make sure we got all of these right. So here's the from endpoint. And let's go grab the to endpoint. And if someone sees in the chat something that I did wrong, go ahead and tell me and it'll save us all a little bit of time. So go ahead and grab that for XYZ. And make sure we got these application credentials right. So hopefully I can get this to work for everyone. Even if it doesn't work, I think the entire flow kind of should make sense here of how we're doing that asymmetric cryptography, of how those on-chain profiles work, and basically how these messages are exchanged. So I'll give it one more shot here and see if I can get this right. All right, one more go. If it's not meant to be, it's not meant to be. So let's try again. Node sender. Okay, so that looks good. I must have messed up the application credentials, and then node receiver over here. Okay, so the messages are being sent. We need to kick off this program so he can consume that inbox, so that he can consume that destination. And again, this will probably be, I don't know, 10 to 15 seconds, and then we'll see a huge stream of messages come in, and then we'll see them starting to be updated in real time as well. So we can look down at the bottom of the terminal, and we see that these are unique messages with a different timestamp coming in, and we see the corresponding timestamps over here as well, 889, 987, 889, 987, etc. So, okay, glad I was able to remedy that. It seemed to be a simple error of application credentials, but these things happen, and this is also testimony and proof that every ingress and every endpoint on Kaleido is securely protected. So you do need to have those credentials and all of those security measures in place. So I'm going to pause there for a second, grab the chat. Looks like there's a couple comments. Yeah, thanks, Harris. I've done these enough where I try to maintain confidence to understand why something might have went wrong. So the last thing I want to show super quickly, a lot of folks may have seen this already, but I just want to show the smart contract management feature on Kaleido and how easy it is to interact with smart contracts, not using Web3 JavaScript, not using Ethereum or a thick SDK or a thick client library, just doing basic web development and RESTful programming. So I'll go into the new Kaleido console here for the latter half of this demo that we have here. And I'm going to go to my consortium level view or my network view. And we're going to use our shared asset class here. And we're going to create a contract project. So this is just going to be a namespace where we can have some source code. We can iterate on the compilations of that source code. And then we can ultimately start promoting it into our environments, into one or more environment. And we can create a very hardened application. So I'll call mine simple storage. It's the one we always use. And I'm going to import it directly from GitHub. I don't have to, paste source code. I don't have to do a compilation myself. I don't have to do any of that heavy lifting, any of those Web3 responsibilities. I can just tell Kaleido about the endpoint to my .sol file, give it that URL, and Kaleido will do all of the other heavy lifting for us. So here's the namespace for the contract project. And now we want to create a compilation within it. So any of these buttons at the bottom or in the top right. So I'll call mine version 1 of simple storage, and now it wants the endpoint. So here's simple storage. For those that haven't seen this one before, it's a single global variable. It's a positive integer, and then it has two methods. It has a set and it has a get, and it takes an argument to the constructor when we instantiate it. So very, very basic, easy to wrap your head around. So I'll copy that URL, paste that right there, and then we can just let Kaleido auto detect all the other information. And this will ultimately spit us out that binary interface that we need to use to encode and decode when we're speaking to the EVM. And it'll also give us the raw compiled bytecode that gets instantiated on the blockchain. But ultimately what it's going to do is it's going to serve us with a set of open APIs that have those methods that we just looked at. We're going to see clean REST APIs for our sets and for our gets, and we'll have a root post method that we can use to instantiate this guide, to actually deploy it onto the blockchain and bring it to life. So there's the AVI, there's the bytecode, there's the dev docs if those are written inline, and now we can promote this to an environment. And again, the idea here is to, harden on your source code, iterate on your solidity, promote it into dev, promote it into UAT, and then, once everything is behaving as expected, you can take that exact same code. You don't have to change anything in your application, and you can promote that into your production or your pre-prod environment. So we are going against demo, I believe. So let me click this guy. And we can just give it an endpoint for those APIs. Call it whatever you want. I'll just call it SS. Choose the environment that we want to promote it to. We're going into demo. And now we're going to have a bunch of open APIs that describe that smart contract, that describe simple storage. So we have no instances. We haven't deployed this on the blockchain yet, but we can go ahead and view those APIs, and then we can choose to instantiate this. So I'll be viewing it through node number 1. That's who I'm going to send the transaction through. In the past, we've talked about a lot of the different signing techniques. So you have this KLD from parameter here when you're using the Kaleido REST API gateway, and Kaleido will let you sign with any key that it knows about. So if you have accounts on your node, or you have accounts in an HD wallet or a Kaleido managed wallet, or even in a cloud HSM, you can enumerate any of those Ethereum addresses, and Kaleido will do all of the redirects and intercepts and sign that object for you. Just as an aside, a particularly useful feature here, if you're going to do signing and account management on behalf of a bunch of end users, where you don't want to have a Web3 application, you don't want to have them externally managing their own keys, this is where you could use an HD wallet instance in Kaleido. So you can very easily map your existing IAM service, your existing LDAP or Active Directory to an index inside of that HD wallet, right? So John Doe equals index 1, Nick Gaske equals index 2. And then it becomes very, very easy for them to authenticate into your identity access management system, and then have that corresponding mapping to the account that you want to sign with them for. So this is just going to be the account on the node here, nothing exciting. We're going to submit it synchronously through our Kafka tier, meaning we're going to wait for that transaction to be mined and executed before we get a receipt. And then we can actually give it a human-friendly name. So we can call this whatever we want and not have to deal with a hexadecimal address when we're talking to the smart contract. So I always just use simple storage 123 as a shorthand. And then again, we need to pass it positive integer to the constructor when we instantiate it. And I'll just keep going with 123 here. So this will take those open APIs, this will take that gateway API that we got as a result of the compilation, and this will give us an instance of the smart contract on the blockchain. This is us not having to use Web3 or do any of the, the esoteric things involved with programming against Ethereum, RLP encoding, nonce management, etc., and just use these basic RESTful calls to instantiate and interact with our smart contract. So I can close this interactive Swagger screen here, close this, and now within our gateway API, we see that we've created a specific instance of that gateway API. We've created a smart contract. And we can create as many instances as we want. And again, this is a particularly useful technique where you have a piece of source code, you have a smart contract, but you don't want to store all of your state on that existing smart contract, right? You may want to separate between different departments or just different divisions or different geographies, but you want the same underlying source code. So you could create an instance for simple storage 123, New York department, simple storage 123 London office, etc. Just to give you an arbitrary example there. And now we can interact with this instance. Again, I'm doing this through the console here, but for a developer, for a programmer, this is a really trivial thing, to do with a basic node program. You just put a little Swagger client in it, you get your application credentials, and you point at the corresponding endpoint, for this instance, for this smart contract. So if you were programming against this, for example, you would want to have some application credentials injected inline, or base64 encoded and passed as a header. But this is the API, this is the URL that you're targeting, and you're submitting those transactions through a node that you own, through node number 1. And then you just have these basic methods here. You could subscribe to the set method, right? This is an event that's been created, and you can get further information. We talked about event streams last week, and we're going to retouch that in an upcoming week once we migrate that feature into version 2. But the idea here is that we don't have to do any complicated Ethereum stuff. We can literally just call post, call our set method, and we can update that state. And we can stream this asynchronously via Kafka. So basically, we're just going to get an acknowledgement from that Kafka topic that it's received this payload, and then we're trusting Kafka, we're trusting the ETH Connect tier of Kaleido to buffer and queue that transaction and submit it to the network at an optimal rate. So we'll give it another argument. We'll take a quick peek at the block explorer. What's the date? Is it the 16th? I'll give it 16 for the day. I think that's right. And this will fire back immediately. So this is just the Kafka topic saying, hey, yeah, we got it. Here's the acknowledgement, and we're going to execute that transaction as it makes sense for your environment and for your algorithm. I talked a lot about the functionality of the REST API gateway. I'm just going to show the picture super quickly, so for some heightened context here. But the idea is this is where we were acting from over here. This would be the application. In our scenario, this was the interactive Swagger interface that I was using. And we were just giving it lightweight JSON objects, right? I was just giving it an unsigned integer inside of some curly braces inside of a JSON object. We uploaded our source code into the API gateway. We had a smart contract project that ultimately turned into a compilation, and then it turned into REST APIs. And then Kaleido surfaced those REST APIs for us to first instantiate those APIs in that source code and then start interacting with an instance of it. And we have this shim, this middleware underpinned by Kafka, that's doing all of the things we don't want to do when we're talking to Ethereum. We don't want to have to compile our source code. We don't want to do RLP encoding. And we really, really don't want to do the sequencing or the nonce management. This is such a huge gotcha that results in queued transactions for all types of projects. And then lastly, we just tell Kaleido how we want to sign this object. Remember that KLD from parameter, potentially the most important parameter in this whole scenario here. All we have to do is tell Kaleido how we want to sign that object. Again, that key could be in the HSM, it could be on the node, it could be in the HD wallet, or it could be in another managed wallet service. So I'll hop out of this screen right here. We'll go back into the console, and then we'll just take a super quick look at the data explorer here. Within the environment, I guess I'm going to show one more thing too. We have this new address book functionality that really gives you a rich, holistic view of all of the runtimes and all of the memberships that are in your business network and in your environment. And it even lets you drill down deeply into specific memberships. So you can see all of the associated signing accounts. You can see all of the nodes, all of the ancillary services like document store, App2App messaging. And you have this, this clear line of sight. So it's fantastic for operators, for administrators that really, really need this, collective view of everything that's going on inside of the network. So for example, if we click our destinations tab, I see that I own 2 destinations, right? These are the memberships, but they're both owned by organization ABC. We can see all the available signing accounts that are on the nodes here. And then we can even dive deeply into our on-chain registry service as well. And you have a fully time-stamped audit log of everything that's taken place inside of the network. So it's a really, really useful feature here that's been exposed on Kaleido. So just to give you guys that knowledge. And then the last thing I wanted to show was just the new revamped Data Explorer and Block Explorer. So we can go ahead and have a dashboard view. This won't be terribly interesting because we haven't done much, but we did a deployment and we did an invocation of that smart contract. And then we can start interacting with these transactions. So this was the one I streamed asynchronously via Kafka, right? It just returned immediately. But we see here that it was executed, that it was mined, and we can see the method or the function that I called, and we can see the arguments that was passed in, as well as the endpoint or the smart contract that we were calling, the transaction hash, and who signed that transaction as well. So you have this really, really rich collection of data that you can drill as deeply as you want to into any of this. So going to pause there, give everyone a couple minutes to throw any questions into the chat. I'm going to also share my email in the chat if you guys do have any technical or business follow-ups that you'd like to engage in. So let me share this with all attendees here. And again, we can dig into your use case. We can talk commercials. We can talk any technical concerns. Really happy to go through any of those packages that I touched on. I'm happy to allow the clients to drive the conversation. And I would also ask a favor from everyone. If there are topics that you are interested in that you'd like to see covered on future Tech Tuesdays, if you do want to see event streams again, or Cloud HSM signings, more private document exchange, more full stack decentralized apps, go ahead and throw those in the chat or reach out to us, and we're happy to structure these and cater these so that everyone gets the most value out of them. Going forward, we will showcase all of the new features as soon as we upload them into version 2 of Kaleido. So you will get document store and you will get event streams again in the next few weeks. But there's such a rich suite of functionality in Kaleido. We have the Ether pool, we have the tokens, we have upwards of 20 embeddable, pluggable services. So I'm happy to dig as deeply as you guys want into any of those as well. Yeah, so a couple of questions. Do you have control over SolC version? Yeah, absolutely, Ian. You can just, the feature I showed was Kaleido just auto-detected the pragma inside of that Solidity code. The other questions is Kaleido a hosted central server? So Kaleido is a distributed, fully managed cloud platform. So we're using servers, across AWS, across Azure, with all of that layer 2 virtual networking, all of that firewalling, and all of the management and auto scaling and DR of those runtime components, right, of the nodes and of those ancillary services, preemptively deploying additional VMs so that your environments can very easily dynamically scale. All of that is hosted behind the scenes here. It can very easily be spread across multiple clouds. You can leverage multiple regions in a single cloud provider, or you can even leverage Azure and AWS within the same business network. We're also continuing work on trying to make a privately hosted Kaleido node a lot more of a streamlined experience, excuse me. So taking that private stack, taking that software, running that on GCP or running that on premise or in a cloud of your choice, but still having the same experience, being able to securely tunnel back into the Kaleido hosted runtimes and still leverage all of those easy, clean APIs and all the functionality that we've shown on Kaleido as well. Okay, so that was the Q&A. I think there's a couple in the chat as well. So the two questions in the chat, this will interface with Hyperledger as well. Yes, we've proven that it can very easily interface with Corda. So I don't think that's a far-fetched idea to say that Hyperledger could be a future protocol. And any of the Hyperledger protocols for that matter on Kaleido. George's question was around the baseline protocol functionality. That question is starting to be asked a lot more frequently. So we're starting to have some internal conversations, but I'm not going to say yes or no to that. But there is a lot of value in that baseline protocol and sort of the service bus and I guess indelibility between enterprises and cross-organizational communications. So stay tuned for updates on baseline for sure. All right, well, I'll give everyone 15 minutes back. There's Tuesday. Thanks so much for attending again. Don't hesitate to email me or reach out. And please let us know if there's other components or other services in Kaleido that you'd like to be demoed on a Tuesday or on a Wednesday. And again, just as a reminder, tomorrow, noon Eastern, We're going to do the Corda 101 walkthrough and deploy a couple core dApps and do the full flow from nothing all the way to a fully running app. So if that sounds interesting, feel free to attend that as well.